Hello Year 12s. So we are moving on to analyzing circuits. So in this topic, the main thing we need is, or the key equations that we need is, current is equal to delta Q over delta T. Then potential difference is equal to work done over charge or energy over charge. Power equals V times I, potential difference times current, and then we have our all-time favorite, V equals IR. So these are the key equations that we are going to use throughout in this. Now basically what we are going to find in all the questions we are going to see is, we are going to find the current, the PD and power rating for each resistor and in total. Okay, so what we have for our question 1 is, we have a power supply of EMF 12 volt. It is connected in series to a resistor of 31 ohms, which then is connected in series to a parallel combination of 12 ohms and 36 ohms. I don't know why I wrote it so teeny inside the boxes. Hopefully you guys can see it. Okay, this is what we have with us. So whenever we get something like this, initially, till we get used to it, I always replace it by the equivalent circuit. So what do I mean by that is, so I have a 31 ohm here and these two are in parallel. So 1 over R is equal to 1 over 12 plus 1 over 36. And when you try to figure it out, you will get 1 over R is equal to 1 over 9, or R is equal to 9 ohms. So this parallel combination can be replaced by a single resistor, 9 ohms, which has the same effect as those two resistors. Now, once we know all the resistances and the EMF, so to find the main current, I is equal to V over R. Main current will be the main voltage, which is the EMF of the cell, divided by the total resistance, which is going to be 31 plus 9. How much is 31 plus 9? You shouldn't take so much time for that. 31 plus 9 is 40. Okay, and you end up getting 0.3 amps. So that 0.3 amps is flowing through these two resistors. So when that 0.3 amps flows around this 31 ohms, what is the potential drop across 31 ohms? Potential drop is current times resistance. So you get 9.3 volt. Then that same 0.3 amps is going to flow through this parallel combination, which will produce a total voltage across them. Now you can do it in two ways. Now you already know that this is 9.3 volt. So the voltage across them, total is 12. So the voltage across them is going to be 12 minus 9.3. So the voltage across 12 ohms is going to be the total resistance minus, the total EMF minus the voltage drop across 31 ohms. You get 2.7 volt. Same across 36 ohms also is going to be 2.7 volt. So now we have the voltages. Now what is the next thing we need to find? We need to find the current. So the current flowing through 12 ohm should be the voltage across 12 ohm. We are again using V equals IR. So voltage across 12 ohm divided by the resistance, which is 0.225 amps. Now once you know this, the thing that has happened here is 0.3 amps came here, went through this, and it has split here. Out of that, 0.225 goes to the top branch. So without doing any other V equals IR equation, so the current that goes through this 36 ohms is going to be, the total current was 0.3. From that, 0.225 amps goes through the top. So 0.075 amps should be going through the bottom resistor. Okay, so now we have all the current and voltages across all the individual resistors and the total current, total resistance. So now let's find out the power. So total power should be the total voltage, which is 12, times the current, which is 0.3, which, so we get it as 3.6 watts. Now let's figure out the individual powers. So the power across 31 ohms should be the voltage across 31 times the current that is flowing through it. You get it as 2.8 watts. The power across, which is the other one, 12 ohms, should be the voltage across that, which is 2.7, times the current flowing through that, which is 0.225, so you get 0.62 watts. Then the power through 36 ohms should be 2.7 times the current flowing through that one, and you get 0.2 watts. Okay, so 2.8, 0.62 and 0.2. What do we get when we add them? We get, when we add these three again, we end up getting, so if I just approximate this as 0.6, we end up getting 3.6 watts. So the power across each component in the circuit adds up to give you the total power. Okay, so that was an easy one, right? So let's then move on to the next one. Okay, so we are moving on to the next question. So this is what we have. We have a power supply. We have two resistors like this. This is resistor A and this is resistor B. This is resistor C and this one is D. So the data given to us is, this is 32 ohms. A 0.25 amps current is flowing this way. 0.75 amps current is flowing this way. Then it says the voltage across B is 22 volt and the voltage across A is 2 volt. So these are the data that we have. Now applying Kirchhoff's second law, I'm going to first consider this loop. So when I consider that loop, the total EMF in the loop, I have only one EMF. So if I label this as E is equal to the sum of the PDs. In this loop, how many PDs do I have? I have this resistor and this resistor. So I should be having two PDs. And those two PDs are 22 plus 2. So we end up getting the total supply voltage as 24 ohms. Okay, 24 ohms. Oops, I'm so sorry. 24 volt. Okay, it looks like it's time for me to go to bed. Then if you consider this big loop, again, the total EMF is E. Then I have a VD, I have a VC, and the current then goes to A. So plus VA. E just now, we found it as 24 volt. VD, we don't know, so let's figure that out. Then VC, we don't know VC directly, but 0.25 amps is flowing through D, so the same should be flowing through C also, isn't it? So VC, if we use I times R, I is 0.25 times R, the value of C was 32, and then VA is already given to us as 2 volt. So 24 is equal to VD plus 0.25 times 32 is a quarter of 32, which should be 8 plus 2. So VD is equal to 24 minus 10. We end up getting 14 volts. So actually now we have everything, isn't it? If we are thinking about A, B, C, and D, if we are talking about the voltage across A is 2 volt, across B is 22 volt, C we just calculated here as 8 volts, and D is 14 volt. Okay, so next we need to figure out I. So we need to figure out the individual current. So current through D is anyway 0.25. Current through C should also be the same thing, 0.25. Current through A is 0.75. Now look at this junction here. So when you look at this junction, 0.25, and the current through B comes there, isn't it? So IB plus 0.25 should give you 0.75. So that means IB is equal to 0.75 minus 0.25, which then gives you as 0.5 amps. So we have 0.5 amps. Now if we talk about power, power is V times I. So 2 volt times 0.75 should give you 1.5 watts. Then 22 times 0.5 should give you 11 watts. 8 times 0.25 should give you 2 watts, and 14 times 0.25 should give you 3.5 watts. So now what should be the total power then? The total power should be 1.5 plus 11 plus 2 plus 3.5. 1.5 and 3.5 should give you a 5. 5 plus 11 should give you 16, plus 2 should give you 18. Okay, so the total power is 18. The total voltage is 12. The total voltage is 24, not 12. I don't know from where I got 12. So total 24 volt. So we have the total voltage, we have the total power, we have the total current. So that's it. We have found out everything in question 2. Oops, we didn't find out one thing. What was that? The total resistance. So to find out the total resistance, either you can go and figure out the individual resistors and then find out the total resistance. But an easy option is total current is 0.75 amps, isn't it? If we know the total voltage and total current, our all-time favorite V equals IR. So R is equal to V over I, 24 divided by 0.75, and that should give you 32 ohms. So keep that in mind. Always we don't need to go for the resistances from the circuit individually, use series parallel combination and figure out the total resistance, you can do it this way also. So these two questions, are you guys happy? Shall we move on to the last one? Okay. Okay, so moving on to the last question. So here we have two EMFs or two power supply. The first one is 20 volt and this is 16 volt. Here, instead of giving us the resistance or current, they have told the power across this is 30 volts. Okay. Then they say the current flowing through this branch is 0.5. They have said this is 20 ohms. They have said this is C, but they haven't told us any individual value there. They have said this is 6 volt and then they have said this is D. So these are the things we have with us. So slightly different from the earlier one. I'm going to figure out all the resistors also in this one. Previous one, if you go back, you can figure out the individual resistors there. Should not be a big thing. Now, when I have a look at it, the first thing that catches my eye is there is two cells. So the total EMF should be 20 plus 16, which makes it 36 volt. Okay. Then when I look at it, if I look here, I can see that a 0.5 amp current flows through B. And B, I know the resistance also. So I can figure out the value, the voltage across or the PD across V as VB equals, the current is 0.5 times 20, which is 10 volt. Okay, so that is the voltage across B. If that is a voltage across B, this branch both should add up to give you then, so that is 10 volt, this is 6, so across this branch it should add up to give you 16 volt, right? Which is then parallel to D. So the voltage across D or the PD across D is the sum of the PD across B and C, because they B and C together is parallel to D. So VD becomes 10 plus 6, which is 16 volt. So this is our, sorry, I forgot to label this. This is our A. So the voltage across A and the voltage across this parallel branch should add up to, say, let's say VD, should add up to give you 36 volt, isn't it? Even though I have written VD, it's not just VD, it is basically this parallel branch, but it should be the same as VD or same as VB plus VC. So VA plus 16 is equal to 36, or VA equals 36 minus 16, you get it as 20 volt. Okay, so that much clear? So now I think we know the voltages across. So again, like last one, if we write A, B, C and D, and if we look for their voltages, VA was 20, VB was 10, C was 6 volt given to us, and D we figured it out as 16 volt. Okay. Now we know the current. The current that flows through B is 0.5 amps. Same current should flow through C because they are in series. Okay. Then for A, we know the power, we know the voltage. So the current across A should be the power across A divided by the voltage across it. So that is 30 divided by the voltage across V is 20. So the current is 1.5 amps. So this is 1.5 amps. So this 1.5 amps comes here and splits into, if it is 0.5 that goes up, then you should have 1 amps coming down. So the current across D is 1 amps. Now we can find the power. So we have a 2 and a 1.5. So we have a 20 and a 1.5. So the power should be 30. If I write the units here, 10 and a 0.5, so that's a 5. 6 and a 0.5, so that's a 3. And a 16 and a 1, so that should be 16. So the total power adds up to 30 plus 5, 35. 35 plus 3, 38. 38 plus 16, 54 watts. Now what is left to find out is the individual resistances. So resistance of A, or the resistance of A, should be the voltage of A, which is 20 divided by the current flowing through it. So A is 20 divided by 1.5. And how much will be 20 divided by 1.5? 30. I will just check, I'm not sure. 20 divided by 1.5. Yeah, 13.33. So 13.33 ohms. Then RB we already know, it is there. If you think about RC, the voltage is 6, the current is 0.5, so it is 12 ohms. Then RD, voltage across RD is 16, divided by the current is 1, so the resistance is 16 ohms. Okay, again to find the total resistance, you know the total voltage. Total voltage is 36. Total current is 1.5. 36 divided by 1.6. I'm just dividing that using my calculator. 24 ohms. Okay, so this is how you figure out the individual resistors, individual voltages, or PDs more correctly, individual current, etc., and all the power ratings and all those things. So now, definitely one question I want you to try is question number 3 on page 180 of your textbook. I'm going to pick a couple more questions from the work pack or the supplementary lockdown limited edition booklet, and I will put that in the instructions. Okay, so I hope you find the video useful. So carry on then. Bye bye.